Did you know that the longest creature in the ocean is not the largest squid species? Even more bizarrely, there are two species of giant squid that evolved completely independently, yet are so similar that scientists have to ask, why did nature create the same biological design twice? Is this merely a coincidence or a profound law of evolution? And if it has happened twice, could a third instance emerge in the future? The story you are about to hear is not just about deep-sea creatures, but also about how nature operates, where effective solutions are always repeated, even in two completely different places. It is exactly this that makes the ocean one of the most mysterious places on the planet. Introducing the giant squid and the truly larger colossal squid. The longest squid species in the world, known as the giant squid, is a creature that can stretch over 13 meters long, exceeding the length of a school bus. It has long appeared in legends of the Kraken or deep-sea monsters dragging ships to the ocean floor. Its image is deeply ingrained in human imagination, leading many to believe that it is the largest creature in the squid family. However, the reality is entirely different because there is another squid species, not longer but much heavier, a creature where each individual carries twice the mass of a giant squid. That is the colossal squid, a species whose body size alone explains why it is considered the heaviest invertebrate ever to exist. This immediately raises a question. Why did nature need two such giant versions? Two unrelated yet similar species. What makes the story even stranger is that these two species are not as closely related as many people think. They are not only different species, but also belong to different genera, and not even the same family. Their first common taxonomic level is only at the order level, meaning the group of squid living in the deep open ocean. Amazingly, in the entire world of squid, only these two species have grown to a size large enough to truly be called giants, while other species are either long but very light, or heavy but unable to surpass a certain limit. This leads to a perplexing question. How could two completely separate species, living in two different regions of the Earth and having never met, evolve into creatures so nearly identical in scale? Evolutionary origins and fossil mysteries. If we go back in time tens of millions of years, it is highly likely that both species shared a common ancestor, an ancient squid that lived around 60 to 100 million years ago during the late Cretaceous period. However, confirming this is nearly impossible because squid are not creatures that leave behind many fossil traces. Their bodies are soft and boneless, so after death, they decompose very quickly, often disappearing completely within just a few weeks. The only part capable of long-term preservation is the beak. If buried quickly enough, these beaks can survive for millions of years and become rare clues about the past. After the age of the dinosaurs, this evolutionary lineage gradually split into various branches. One branch led to the giant squid, while the other developed into the glass squid family, which includes the colossal squid. From here, two completely separate evolutionary paths began. What is convergent evolution? The most important thing to understand here is that the massive size of these two species is not something they inherited from a common ancestor, but rather the result of each species evolving independently to reach that size. This is a prime example of convergent evolution, a phenomenon where two unrelated species develop similar traits because they face similar environmental conditions. It is not that they learn from each other, but rather that nature is repeating a solution that has proven effective. Like an invisible law, if a design works well, it will appear multiple times. But if so, why do these two species still have so many differences? What caused them to head in the same direction but not end up exactly the same? Habitat differences. The answer lies in their habitats. The giant squid lives primarily in temperate oceans and has a wider distribution range, whereas the colossal squid only exists in the deepest and coldest waters of the Antarctic. The giant squid grew to its massive size due to deep-sea gigantism, where high pressure and extremely low light create conditions that cause creatures to tend to grow larger. Meanwhile, the colossal squid is heavily influenced by polar gigantism, where freezing temperatures cause bodies to grow larger to better retain heat. Although both live at great depths, the primary reasons for their gigantic sizes are not entirely the same, and this very difference has led to highly distinct characteristics. Comparing size, speed, and shape. When observing their bodies closely, you will see clear differences. The giant squid has a long, slender body designed for fast movement. Its tentacles can reach far out to catch prey, but its average weight is only about 200 to 250 kilograms. In contrast, the colossal squid has a much thicker, sturdier, and heavier body, with individuals capable of reaching over 600 kilograms, making it the heaviest invertebrate on the planet. The giant squid can reach speeds of up to about 40 kilometers per hour, thanks to its jet propulsion mechanism, while the colossal squid is significantly slower, at only about half that speed. This shows that these two species differ not only in size, but also in how they move and survive. Completely different hunting strategies. The difference in shape entails a difference in hunting strategies. The giant squid lives in an environment where prey moves quickly, so it must be faster to survive. Its light and agile body helps it dart toward prey in a split second. It uses its massive eyes to detect movement in the dark, then accelerates to catch prey before they can escape. Its tentacles feature suckers lined with small teeth to help grip slippery prey. Meanwhile, the colossal squid lives in a freezing environment where energy must be conserved. It does not chase, it waits. Its thick body helps store energy and retain heat. When prey approaches, it launches a decisive attack. Its tentacles are equipped with sharp, swiveling hooks that securely lock onto the prey. This demonstrates that despite both being deep-sea monsters, their ways of surviving are entirely different. Beak structure and feeding habits. Despite their different hunting strategies, both species evolved a similar trait, an incredibly powerful beak. In the deep ocean, there are no hard surfaces to hold prey against, so they need a tool capable of slicing through flesh and bone right in the water. The beak is made of chitin, a material similar to insect exoskeletons, but reinforced into an extremely rigid structure. The two halves of the beak act like a pair of scissors, cutting the prey into pieces. Then, a tongue-like organ with small, backward-facing teeth shreds the food before swallowing. This is a perfect solution for eating in an environment without leverage. The sperm whale, the predator of both. Although these two squid species never meet in nature, there is one creature that knows them both well: the sperm whale. This animal is large enough, strong enough, and capable of diving thousands of meters deep to hunt both the giant squid and the colossal squid. They use echolocation to find their prey in complete darkness. Their bodies often bear scars from the squished suckers and hooks, and in their stomachs, scientists have found the beaks of both squid species, the only parts that remain undigested. This proves that the sperm whale is the common predator of both giants. The evolutionary arms race. The existence of the sperm whale creates a continuous evolutionary arms race. As the squids grow larger and stronger to avoid being hunted, sperm whales also evolve to dive deeper and hold their breath longer. Both sides constantly push each other to their limits, while simultaneously having to adapt to other environmental factors. This shows that evolution is not a perfect process, but rather a continuous balancing act between various pressures. Other examples of convergent evolution. The phenomenon of convergent evolution does not only occur in squid. There are many similar examples in nature. Sharks and dolphins share a similar shape for fast swimming, despite belonging to two completely different groups. Bats and birds both have wings despite evolving independently. Even in Australia, there once existed a marsupial that looked like a wolf despite having no close relation. This demonstrates that nature is constantly experimenting with and reusing effective designs. Could there be a third giant squid species? So what is needed for a third giant squid species to emerge? The answer is the same conditions that created the first two: dark, cold, or high-pressure environments. In fact, there are already squid species in intermediate stages. They have not yet reached gigantic sizes, but are showing signs of this process. Given enough time, millions of years of evolution could produce a new squid species of colossal proportions. And that might be quietly happening right now. Nature does not create giant creatures just to be impressive, but because they are truly effective designs for surviving in harsh environments. The story of these two squid species shows that evolution can repeat itself in astonishing ways. If you found this content interesting, please hit like and subscribe to the channel so you don't miss out on the next fascinating stories.